Hello everyone. So we're going to be learning about inequalities in this section. 4.3, solving compound inequalities. That's going to start on page 141. Remember that's M2 should be in front of it, so m2-141. So we've already learned about how to solve equations and how sometimes they have infinite solutions and no solutions. Now we're going to be looking at how to solve compound inequalities. Now, for instance, an inequality is something that uses the symbols like less than, greater than, less than or equal to, or greater than or equal to. So you'll probably see something that looks very similar to an equation, but you're not going to see an equal sign anymore because it's not an equality. It's not equal, it's an inequality, which means it's not necessarily equal to. Okay, so you're going to see one of four of these symbols in your problems. Okay, so let's go ahead and start talking about what a solution actually means. Now, it does tell us, remember that a compound inequality is an inequality that is formed by the union or the intersection and of two simple inequalities. So what this is telling us is that if we have a union, that we're going to see the word or in our problem. If we have an intersection, we have the word and in our problem. So let's talk about where union and intersection actually come from. So when I think of the word union, okay, so I'm going to make a couple of notes. Union. When we think of the word union, we need to think about uniting all answers. Unite all answers. Okay? Now, when we think of the word intersection, we're going to find where they overlap. Where do they intersect? Okay? So I'm going to write this note as well. Intersection. This is going to be where they intersect, where they overlap. The overlapping answers. So the overlapping answers, you can also say this is what answers they share. Let me reword it as shared answers. How else did we say it? Where they intersect. Where the answers intersect. Okay? So there's a couple of ways we can think of intersection. There's now union. We just want to think about it as we're uniting all the answers. So the union is going to be every possible answer that we can think of, and that's when we use the word or. Okay? So I'm going to put the word or right next to it. So if you see the word or, that's a huge hint that you're going to unite all the answers together. Now the intersection, this is going to have the word and. Sometimes it won't have the word and. We're going to talk about that in a second. But I'm going to draw a little picture to kind of show you what we mean by intersection and union. And we can think about them as Venn diagrams. So I'm going to draw a Venn diagram. Okay, so when we use a Venn diagram, to be familiar with a Venn diagram, you know that we have two circles, and where they overlap is the answers that they share, right? So where they overlap, these are shared answers. So that's going to be our intersection. What do they share? Because they can have things in each circle, but whatever's in the center, that's what they're going to share. So if we have an overlapping portion, which we're going to have an overlapping graph, which you'll see in a second. If we have an overlapping section, this is going to illustrate our intersection. Now, for the union, let's say that we had the same thing. Now, I don't care what's overlapping. we can use what's overlapping, but we're also going to use anything that's not overlapping, because if we unite everything, so all these dots here, if they were options, we would want to select all. So where we have all of them, all options, right? And this is going to be for our union. Okay? So our union, our intersection. So that's kind of a little visual way for us to think about union and intersection. So let's keep going. It says that the solution of a compound inequality in the form A is less than X, which is less than B, where A and B are any real numbers, is the part or parts of the solution that satisfy both of the inequalities. So this is a special case. Okay, that's a special case that doesn't say and or. When you see it in this form, A less than X less than B, this is always going to be and. So this is identified as which one is and? So we're going to look over at our notes over here. And represents intersection. So we're looking at the intersection, where A and B are any real numbers, is the part or the parts of the solution that satisfy both, right? If they satisfy both, then that's where they overlap, right? So when we have an inequality in that form, automatically dead giveaway that it's an and. If it's not like that and it says the word and instead of looking like that, then we know that it is also an intersection. So it'll either say the word and, or it'll be in this form for it to be an intersection. Okay? This type of compound inequality is called a conjunction. So if we have a conjunction, we're looking for the intersection. Okay? So if we have a conjunction inequality, we're looking for the intersection. So I'm going to put a little note there as well. Conjunction. Okay, so we're looking for the intersection when we have a conjunction. All right, on the other hand, the solution of a compound inequality in the form X is less than A or X is less than B, where A and B are any real number, is the part or the parts of the solution that satisfy either. So it can satisfy either of them, right? Notice this word or. It says the word or. It specifically says or. So in this case, we're not going to have a special form. It will always have two inequalities and have the word or in it. So if we have the word or, what type of solution are we going to have? We're going to have the union. So we're going to put all the answers together. We're going to say these are the answers or these are the answers, and we're going to put them all together and unite all of the answers together. So notice how it says that it can satisfy either of them, because it could be this or that. So it's going to satisfy either of them. So this type of compound inequality is called a disjunction. So if we have a disjunction, okay, if we have a disjunction, we're looking for the union. Okay, we're going to unite all the answers together. That is or. All right, so hopefully you had that stuff written down. If not, please pause the video so you can go ahead and write any annotations so that you have all this information. But I'm going to go ahead and erase it and move on. All right, so we're gonna stop by, we're gonna move on from number 1. Go ahead and cross it off, and then we'll see a worked example. So let's consider the 2 examples that were given here. Let's consider 2 examples for representing the solution of a compound inequality on the number line. The compound inequality shown involves and is a conjunction. So remember, we have the word and. It's a conjunction. So what is conjunction again? What do we need to look for? We're looking for the intersection. So I'm going to go ahead and write that word here. We're looking for the intersection. And what does the intersection do? The intersection is where they overlap, right? Overlap or share. Okay? So if we have these 2 inequalities, x is less than or equal to 1 and x is greater than -3. Notice the word and, right? It's intersection. Notice the word and. if we have those two inequalities, let's go ahead and actually graph them. Now, I'm not going to graph them directly on a number line. I'm going to graph them separately above the number line. So represent each part above the number line, right? So that's your step one. Each part we're going to represent above the number line. So here's our number line. So let's go ahead and graph x is less than or equal to 1. Now remember, less than or equal to means closed circle. So we're going to fill in that dot at 1, and then less than means we're going to go to the left. Now greater than -3. Remember, when it's just a greater than with no equal to part, we're going to have an open circle. So now we're going to have greater than -3. So we're going to have open circle at -3. And we're going to go to the right. Everything greater than -3 goes to the right. All right, so we have each part. Each part is graphed above the number line. But what is the answer to this? Well, since this is an intersection, we're looking at where they overlap. So where do they overlap? They overlap in this portion right here. Okay, see how they overlap there? And then after we go more left to -3, it's just the blue line. And when we go to the right of 1, then it's just the green line, right? They only overlap between -3 and 1. So how are we going to graph that? We're going to go ahead and graph that. I'm going to use red. We're going to go ahead and graph that by just dropping down our open circle at -3. Open circle. We're going to drop down our closed circle at 1. And then we're going to connect them and kind of show where they're overlapping. So that is our graph. This graph right here, that is our graph. That would be our answer. And this graph represents x is less than 1 and x is greater than -3. Now remember, this looks just like domain and range, which we talked about in first semester. So we start from -3. -3 is our lowest point, 1 is our greatest point, and everything is, we're going to go ahead and say, since this is domain, right, going left and right, this is represented with an x, and less than for -3 because it is an open circle, and then less than or equal to for 1 because it is a closed circle. And notice they rewrote it using this is called a complex sort of format, which is how we used to write our domain. Okay, so if you have a conjunction, I'm going to ask that you do rewrite it in this form. You just take the lowest value, put it on the left, the highest value, put it on the right, and then use your inequalities as needed, less than or equal to or less than, depending on if the circle is open or closed. Okay, so these are the solutions in the region that satisfy both inequalities. Graphically, the solution is the overlapping or the intersection of the separate inequalities. All right, let's look at a disjunction now. All right, next worked example. The compound inequality shown involves or and is a disjunction. So we're going to have the word or. It's a disjunction. So what is disjunction again? We said disjunction is the, it's not the intersection, but it is the, union, right? So we're going to have the union. What is the union again? The union is uniting all answers. All right, we're going to put everything all together. So I also like to say all together. All right. So notice how this inequality literally says or in it. X is less than -2 or x is greater than 1. That means that it is a disjunction. We're going to find the union. So our first step, represent each part above the number line. All right, so we're going to go ahead and graph the first inequality. X is less than -2. So less than, remember, it's going to be open circle. So open circle at -2, and then less than it is everything to the left. Now we're going to graph the other one. Open circle because it is just less than, or greater than, I apologize. So open circle, everything greater than, goes to the right. So now we have those two inequalities graphed separately, but now we need to unite all of the answers together. So we're not looking where they overlap. We're trying to unite all the answers. So we're going to take, I'm going to circle it in red. We're going to take all of these answers, right? All the answers that are graphed for that inequality, and unite them with all of these answers on the number line, on one number line. So we're going to put them all together. So we're literally going to just take both these number lines and just drop them down. Okay, so now you can see that the answer is both of them on the number line, because we're going to take the answers from the first inequality and put them together on the same number line with the other answers for the other inequality. And that means we're uniting both the answers to both of those inequalities. So the solution is the region that satisfies either inequality. Graphically, the solution is the union, or all the regions of the separate inequalities. All right, let's go ahead and move on. Let's try, trying to move on here. There we go. Let's try number 2. So it says, consider the two worked examples in a different way. If the compound inequality in the first worked example was changed to a disjunction so that it said or instead of and, how would the solution set change? And explain your reasoning. So what we're going to do is we're going to go ahead and graph both of those separately. Right? So we have the two inequalities. X is greater than -3. So I'm going to go ahead and plot them. Then I'm going to have x is less than or equal to 1. I'm going to go ahead and plot those. Now, since we're doing or, right? Remember, this is or. Or means disjunction. So we're dealing with a disjunction. Now, in this case, disjunction, remember, is uniting all answers. So we want to unite all of them. We want all of this number line and we want all of this number line. Now, if I go ahead and look at both those number lines, it looks like we're just going to have a full-on line, right? Because all of these answers for x is less than or equal to 1, it's going to keep going on forever that way. And all the answers for x is greater than -3, they're going to keep going on this way. So it looks like it's just going to be a full-on line, right? So if I drop both of the number lines together now, we're going to go ahead and have something that looks like that. And it's actually all numbers. So that red number line that I have there, those are our answers. And so we would explain the way that we would answer this is that they are all real numbers, right? And we're going to visually graph them as a full line. So the solution set would change to be all numbers less than or equal to 1, including all of the numbers greater than -3, and that's any number imaginable. Okay? So for the next part, now we're going to look at the other worked example. It says if the worked example, or the worked compound inequality in the second worked example was changed to a conjunction, so now this time we're dealing with and instead of or, how would the solution set change? So let's remind ourselves. We have an and this time. This is a conjunction. So since this is a conjunction, we're going to find the overlapping part. Overlapping section. Okay, so we're going to look for the overlapping section. So let's graph both of those inequalities separately and then find where they overlap. So I graphed both of those separately. There's x is less than -2 and x is greater than 1. We want to find where they overlap. Where do they overlap? I don't see where they overlap. What could this possibly mean? If they don't overlap, then there can't be an answer. So in this case, there's going to be no solution, right? Oops, let me go back. So the solution set would change to be all numbers that are less than -2, but also must be greater than 1. There's no number that satisfies these conditions, so there is no solution to this case. All right, so I hope that this has explained it. Remember that your first step should always be to graph each inequality separately, and then go ahead and find whether they're overlapping or unite all the answers, depending on if it was a disjunction or a conjunction. All right, so I'm going to have you go ahead and finish the rest of these. So use number 3 as a way to practice, and we will talk about them later.